Good afternoon, everyone. My name is Don Parkinson, and I'd like to welcome you back to another in our series of Northern Road Link live streaming sessions. Every other week on Wednesdays at this same time, we will discuss a new topic, and we want to encourage you to provide as much input as possible by calling or texting us with your questions or comments. However, today we don't have calling or texting available, so you can email us at info@northernroadlink.com. That's info@northernroadlink.com. And just to remind everyone, we are doing these radio shows and streaming sessions to help community members and the general public get a better understanding of what is involved in the federal impact assessment and provincial environmental assessment processes, and to encourage viewers and listeners to participate in both of these activities. With me today is my usual co-host, Mr. Qasim Sadiq, who is the project co-lead for the Northern Road Link project. Good afternoon, Qasim. As always, you and I have a full plate to discuss today.
Absolutely, Don. Good afternoon to you as well, but a very exciting and relevant topic for our project.
Absolutely, and today's session is called Field Studies, Fish and Fish Habitat. And in this, we're going to talk about the fish and fish habitat investigations or field studies that are going to be done and have started to be done as part of the environmental and impact assessment. So, Qasim, before we get started, maybe you can do a quick run through of what we're going to cover today on slide number 2.
Absolutely, Don. So in today's conversation, we're going to cover 7 things. The first one is talking a bit about the objectives of field studies. Second one is what will be assessed in the studies. Then we talk about preliminary baseline description within this particular valued component. Then we discuss the field study in more depth. So we discuss fish habitat assessment, environmental DNA sampling techniques, conventional fish capture, and then opportunistic benthic sampling. Then after that, we talk a little bit about potential mitigation methods available, and lastly, criteria and indicators. And of course, as always, we leave our contact information with our audience at the end on.
Thank you, Qasim. And let's start now with a brief discussion of the objectives of the fish and fish habitat field studies. So if we can switch to slide number 3. So there's 3 main objectives to these field studies for fish and fish habitat. The first is to identify and consider impacts of the project on aquatic habitats. The second is the reverse of that. It's to identify and consider the impacts of aquatic habitats on the actual project. And then the final objective is to provide recommendations for minimizing or limiting negative effects related to aquatic habitat impacts during construction. And those effects could be environmental, they could be health, they could be social, project constructability impacts, or economic impacts as well too. So they're wide ranging. Qasim, maybe you can go through now what will actually be assessed in the studies regarding fish habitat.
So this is the part where we concern ourselves with both the quantity and the quality of the habitat. So habitat availability starts to examine both the quality and the quantity of the habitat. By quantity, of course, it's that part is self-descriptive, but you're looking at the potential changes to the total area of habitat and any known or assumed critical life cycle habitat like spawning, rearing, etc., affected by construction and operation maintenance of the road. And the habitat quantity is something that you assess quantitatively. You try to put a number on the quantity of habitat available for for the fish and fish habitat study. Then comes the quality part that is assessed qualitatively which includes changes to the quality of spawning, rearing, or overwintering type habitats for criteria species. And some examples in our case can include brook trout, northern pike, walleye, and lake sturgeon, and consideration of other species that may be consumed or have high value for indigenous communities around. So, species that have cultural importance. They could be species like whitefish, chain pickerel, yellow perch, cisco, burbot, long nose sucker, white sucker, lake chub, etc. Then the last part relates to habitat sensitivity. And that is something that you assess and rate at each water body as either rare, high, moderate, low, or no fish habitat based on species sensitivity, species dependence on that habitat, rarity of certain types of habitat, and ability of certain habitat to recover from change, which really is the factor of resiliency. How resilient a certain habitat might be. So these are the different factors that are assessed for the habitat on.
Thank you, Cossum. And let's now look at what will be assessed regarding fish communities. If we can go to slide number 5, please. So, in terms of fish communities, we'll be looking at fish communities themselves. We'll be looking at spawning, and we'll be looking at benthic invertebrates. So, with regard to fish communities, we'll be looking at abundance and distribution. Abundance refers to direct changes to the population, um, or direct and indirect changes to the population because of changes to habitat availability. There may be less habitat available, or those areas are smaller, some sort of impact in that sense, and that may affect survival and reproduction. When we talk about the distribution part of fish communities, we're talking relates to what you call the spatial configuration and connectivity of habitats. So the shape and size of these particular habitat areas, and then how these relate to each other spatially. So how are they connected? Are there a series of different habitat types strung together that might represent the life cycle of a particular fish species? Things like that. And then when we look at spawning, we'll look at effects on the spawning activity of fish, and then the extent of spawning habitat that's present in the project area. Um, and we'll try to quantify potential direct effects such as lost habitat through construction of the road, and then provide a bit of a qualitative assessment of indirect effects to spawning habitat. And then finally, we're going to look at benthic invertebrates, and we'll get into this in more detail later. But these benthic invertebrates are creatures that live at the bottom of watercourses or water bodies, and these are important creatures because they reflect the health of the environment. They're sitting at the bottom of that environment. They're taking everything in, so they're very good indicators as to the health of the environment. So by collecting information on these benthic invertebrates pre-project, we have a good way of measuring any impacts after the project is built or while the project is being built. And Cossum, maybe now you can sort of set the stage and describe to an extent and describe the baseline, sort of describe the project area and as it relates to fish and fish habitat.
So this project area or the regional study area, which we concern ourselves with, it has many different water bodies that include streams, rivers, lakes, ponds, wetlands, and all of these provide direct habitat and support for many different fish species. The largest river crossing in the regional study area is the Arawapiscat River, but there's also a vast network of smaller connected headwater streams, ponds, and lakes. The larger lakes and watercourses, they provide year-round fish habitat. but the smaller, shallower lakes and wetlands, they often do not. And that's because oxygen levels can drop and they can be quite low. And that creates hypoxic conditions, which means that there just isn't enough oxygen for fish to live in such conditions. However, the smaller watercourses and lakes, they can provide suitable habitat for rearing and feeding for some parts of the year, which typically is in early spring. Uh, the Arawapiscat River, being the largest sort of water crossing in the regional study area or in the project area, supports populations of walleye, lake sturgeon, brook trout, lake fish, and other fish species as well. But then you've got a number of lower energy water courses, and they're connected to these rivers, and they provide vital habitat for walleye as well as northern pike. Now, the regional study area is really quite rich in fish species diversity, and we've got about 32 different fish species across the regional study area here, Don. And one of these happens to be a species at risk within our regional study area.
Yeah, it's a pretty incredible area for fish and fish habitat. That's why it's so important to characterize it really well and really comprehensively. And let's talk now about the fish habitat assessment component of the field studies. And this involves going to different areas, different habitat types, and conducting uh, surveys. Using established protocols, one of which is the Ontario Stream Assessment Protocol, um, capturing information about particular habitats, and these assessments will characterize um, the biophysical features of these areas and other aspects as well. But they'll record information such as water body name, the watershed that it's part of, water body type, the temperature of the water course, flow and velocity of the water at the time, physical characteristics of the channel through different types of measurements, such as bank full width and wetted width, uh, measuring the depth of any pools, measuring water quality, and looking for the presence of cover or overhanging vegetation that provides shelter for fish. That's often an indicator of an important habitat indicator. Substrate type as well. Substrate refers to the bottom of any water course or water body. So it could be a rocky bottom or a gravelly bottom or a silty bottom or sandy bottom. That's what substrate refers to. And then stream gradient as well too, which is basically the slope of the stream over a certain distance. Other information is presence or absence or density or other characteristics of riparian vegetation. Riparian meaning vegetation that is adjacent to, beside water courses or water bodies. And then also the presence of any barriers to fish passage, such as beaver dams as well too. So there's a lot of information that's collected. It's a very important activity to characterize these fish habitat areas biophysically, and those are the kinds of activities associated with it. And Casa, maybe now you can talk a little bit about a really interesting activity, and that's environmental DNA or eDNA sampling.
It is. It really is a cool and interesting technique, and I think people know about this now more than they've known about it in the past, because with COVID-19 pandemic, one tool that public health agencies use to track the pandemic when you didn't have easily available testing was environmental DNA sampling. And you'd recall, at least in the newspaper, they talked about sort of sewage sampling, just to see what's in the environment. So it's a similar idea in which environmental DNA sampling is conducted to characterize fish community and also to augment or improve the conventional fish capture data available in a project. This technique is cost effective. It is non invasive as a strategy for acquiring information on fish and other aquatic organisms from water samples. So it is effectively being able to tell just from water samples what type of fish and other species are have left their DNA or DNA marker of some sort in that water sample. So eDNA is obtained from water and it reveals important information about past and present biodiversity. Now you can target organisms which can be detected at any life stage, including in the egg, larval, and juvenile forms from eDNA samples. And all species in our natural environment, we shed DNA in some shape or form. Either that's through dead skin or a hair that we've lost, or some other sort of biomarker which we continuously leave in the natural environment, which provides a tool to scientists to collect information and data about what's in that environment. And that's the method we utilize in the project as well, Don, which is known as eDNA sampling.
Yeah, it's a really interesting activity, that's for sure. I've seen it done in the field, and it's just a really fast and useful method that generates, as you mentioned, a lot of information. Thanks for that, Cossum. And next, let's move on now to a discussion of conventional fish capture sampling. And so, beyond using the eDNA methods, in some situations we may use the more conventional methods, and these are done again to characterize the fish community by looking at the different species and the different life stages that they may be in. So. This may be done in certain water bodies, and some of the conventional methods are hoop nets, angling, actually fishing, seine nets, minnow traps, or actual backpack electrofishing, which is a method that's been used for about the last 20 to 30 years, I would say, in the mainstream. And so typically, the fish captured would be quickly identified as to species and measured different measurements, physical measurements, weight, and different linear measurements would be made of the individual fish caught, and then they're released back to the water body where they were captured. So those tried and true traditional methods will still be used on occasion. As and there's certain situations where it makes sense. So, Qasim, maybe now you can talk a bit about another interesting activity and an important activity because of the importance of the information gleaned from it, and that's opportunistic benthic sampling.
Another really interesting technique, Don, and as I've said before, it's a bit of a storytelling technique in the project. So benthic invertebrates are aquatic creatures with no spine, and they generally live at the bottom of water bodies. And benthic invertebrates, they're often sampled in aquatic monitoring programs, mostly because they're responsive to environmental alterations and they're good indicators of ecosystem productivity and health. So if all you've done is you've spent your sort of life at the bottom of a water body and you've fed over there, the natural tissue becomes a great source of information around the type of sediment available, contaminants in that sediment, and so many other factors. And you can tell that story through opportunistic benthic sampling using eDNA, but also conventional sampling methods. Now, in terms of the conventional sampling method, on the benthic sampling side, it includes a ponar grab sample, which is a bit of a scooping device, and it helps take a sample from the base of the water body. The ponar grab, it's a device widely used for taking sediment samples from more hard bottoms, such as sand, gravel, or clay type surfaces. The poner grabs a sample of sediment from the bed of a stream, river, or lake, and then within that sample, you've got those benthic invertebrates. So then the scientists, they spend a little bit of time going through that sample of sediment to identify the benthic invertebrates, and then of course that helps you collect the data that you're looking for.
Thank you, Kasim. Let's talk now a bit about criteria and indicators associated with fish and fish habitat. Um, so criteria or valued components are what are being studied, specific, and then the indicators are measures or different ways of different measurements. So in our case, the valued components are fish habitat and then fish and aquatic species, including species at risk. So two main valued components. So the fish species include all fish that occur in the study areas, but there are certain species that are highlighted because of their importance, and their importance, whether it's ecological importance or biological importance, or their, for example, cultural importance or recreational importance. So in our case, we'd probably be looking at species that are important to community members because they use them as sustenance, as food. And so they're very important species. So some of these would be a walleye or brook trout or northern pike or lake whitefish, burbot, yellow perch, common white sucker, lake sturgeon, or lake chub. And the indicators used associated with each of these, which associated with the criteria of fish and aquatic species would be habitat quantity, it could be distribution, and so these are the different measures, right? These indicators are different measuring tools. So it could be habitat quantity, it could be distribution and connectivity to the habitat and migration, and it could also be survival, reproduction, and abundance. Now, looking at the preliminary indicator of fish habitat, for fish habitat, the valued component, they could be in situ water quality, so the actual quality of the water. We take a sample of the water and get it chemically tested. And it could also be physical habitat conditions, whether it's the substrate, remember the bottom type, or the cover, meaning a vegetation hanging over the water or actually in the water, or it could be the depth of the water as well. And then another indicator of fish habitat could be, as we talked about before, the benthic invertebrate community. So the diversity of species of benthic invertebrates in samples, the number of individuals associated with each species serves as a very good indicator as to the health of the aquatic environment there. And Kasim, maybe you can talk a little bit now about a really important topic and one that sort of um, evolves over the course of the environmental assessment, and that's potential mitigation measures.
It does, Don, and to be able to sort of choose mitigation measures, first you've got to sort of identify all the different ways in which a project will come to impact the natural environment. But at a high level, at least on a project of this sort, the road project, there are a number of different potential mitigation measures available. So you could identify alternative sites for temporary or permanent aggregate extraction pits and production facilities that are needed for construction and operation of the road, including access roads to these sites. So you just move from one alternative to another based on the potential impact of an alternative. Identifying alternative sites for supportive infrastructure as well makes a big difference. For example, temporary laydown and storage areas where you put your construction camps, including access roads to these areas. Watercourse crossing structure types make a difference in certain circumstances as well. For example, between culverts and bridges, how long is the span length, the life cycle, construction staging methods at water body crossings. They can potentially make a difference to the impact that the activity has on the natural environment, on fish and fish habitat particularly. Watercourse crossings can be sized to account for potential future increases in flood intensities, which we know with climate change, that flood intensity keeps on, even though it oscillates and yo-yos quite a bit, but in the long run, it really just keeps on going up. So you have to account for that. Watercourse crossing inlet outlet that can be armored to mitigate against erosion. Watercourse crossings, they can be designed to allow for fish passage. Now that's a bit of a useful but simple technique, which allows for fish to go from one side to another side. But again, it's a design element which you need to think about at the front end, and you need to think about how will it help mitigate potential impact on fish. Then you've got the engineering and design side of things, which can also help mitigate some potential impact on fish and fish habitat. Road topping and embankment material and geometry, things like gradation, depth, etc. They can be designed to accommodate potential increases in rainfall intensity, for example, that could lead to washouts. Now, you know that if something like that is going to potentially affect fish and fish habitat, you want to account for that in at the design stage. Operations and maintenance, now those can incorporate appropriate grading techniques and material storage to minimize erosion of stockpiled material. Now that becomes an easy source of washout. So just putting more thought and process and purpose behind what that can do, you can help mitigate some of those effects as well. And then the road can be designed and constructed with a slope or a grade to allow appropriate surface drainage, which makes potentially a difference to fish and fish habitat. So these are all the different type of ways. It's a bit of a laundry list on, but these are all the different ways in which the utilization of alternatives of different design and engineering techniques can help mitigate the potential impact of a project on fish and fish habitat. Now, as we go through the environmental assessment, we'll know which ones work better in our case. And I think we'll talk about that in the future, but this is a bit of a laundry list at this stage.
So true, Cossum. And as we learn more, as you mentioned, as the project evolves and we learn more about the environment that this project would be built in, we can really refine that those mitigation measures, whether it's the technique itself or the actual geographic areas where that technique is applied as well. So that's something that goes on throughout the environmental assessment phase. So that wraps up today's NRL discussion. And thank you, as always, Qasim, for sharing your thoughts in this discussion. I hope our viewers found it helpful in understanding the field studies associated with fish and fish habitat. And we will be back again in 2 weeks when we talk about water, and that's surface water and groundwater related field studies, which is a topic that's always of interest to community members because so don't forget to visit our website at northernroadlink.ca or follow us on social media at NRL Roadlink. You can contact us again at info@northernroadlink.com. The website is there, as you can see. You can also call us and leave a message as well. So thank you again, Miigwech, for joining us. Thank you, Qasim, and we will see you again in 2 weeks.